This is Grant, Z01WTT. I'm about to show you a simple rundown on how my DATV software interface works with VLC. As you can see, I'm running it from a Linux desktop. So first of all, we'll run the application, other DATV playout. This particular application is a .deb file, which you can simply install through the Ubuntu Software Center, and it's very easy to actually install and get up and running. You'll see I've provided for 4 input devices: File, Video for Linux, PVR and RX. And as I move across, you can see, you can configure that. You can configure these 2 boxes down here for the PVR input, the video side, the sound side. Up here, your threads for the number of CPUs you wish to share the load across. And down here is the receiver configuration, which allows you to take it in from another satellite tuner card, analog card, and basically lets you configure it. PVR input device, you can select video 0, particular input, video. Down here I've actually said for file streaming, if I hit this, it will ask me for a directory. And if I move down here to my ATV folder, you can see it just brings up that directory. I hit open, and then it asks you wish to do loop random. And we move down here, it's for your video PIDs for the stream, video, audio when I've defaulted, and your IP address you wish to stream to on your network. And it's very important to work with static IPs so you know where your modulator is or your IP to ASI converter lives on the network. And if I just hit update, you'll see that it's come up with all the information in an editor and the PVR device and all the default settings. And the beauty about this is I could save as a shell script file, and you can basically launch this as an independent file, independent of my software, and it will automatically launch your preset preferences for streaming. So that's a brief rundown on how all that works. What else can you do with my software? Well, if we go up to setup, we have a timer. This timer will automatically play out media files or PVR streams at different times of the day to a fixed IP address or any IP address, and all driven from the desktop clock. We've also in here got a simple multiplexer. We'll bring that up. You can see we have the 3 inputs. We've added a IP in, which is very useful if you're running streams from different computers on the network. You can combine them into the one multiplex stream. And as you can see, you've got the different streams you can individually configure. If you hit select all, this will allow you to send the multiplex stream to one IP address. If not, you can demultiplex and have multiple streams coming in from different IP addresses and send them out to different IP addresses. But by locking it all down to the one IP address and port, you're sending the one complete multiplex stream. If we hit update, again, this will generate a VLM file that you can be run virtually directly through VLC, providing all the information for the multiplex. Okay, I've also incorporated the viewer. This is a very useful tool if you just wish to have a look at IP streams coming in. And I've also provided a PVR output function. If you can get your hands on a PVR 350, this is a very valuable card to have because it does provide the function of looping video out and video in. So you can do a complete loopback test. You can take a stream coming in and you can loop it straight back out as MPEG-2, because these particular cards contain an MPEG-2 decoder and an MPEG-2 encoder within the same chipset. So very useful tool for actually looking at the stream directly on a display device like a TV or so forth. If we look right down here, this is the advanced setting I've designed for IP streaming, where you can stream out on the internet, stream in on the internet, and do some very interesting functions. Again, if we just click that, it just brings up a file that you can save. Now let's look at how it all works. I've now connected up an HVR 1900, which is a USB 2 MPEG-2 encoder box. And by default, the PVR selected MPEG-2. But I would like to increase the bit rate, so we'll just bring it up to 5.1 megabits per second. Scale we'll leave at 1, which is 720 by 576. Threads is non-applicable because we're doing the encoding within hardware, not within software. and we'll leave everything as default to keep it simple. Now we've got to move down to Video for Linux and PVR device and select the device we have now connected up. In this case it's device video 1. And we're going to work with S-Video coming in, so we'll select S-Video. And if you're happy with all that, and we'll have a look down here, the PIDs. If you're happy with the PIDs, IP streaming address. In this case, I am streaming to an address of 150, and the port is defaulted to 1234 for UDP packets. So we'll do an update. And this will generate in the text window your shell script file, which you can save as a .sh file and run as an executable without actually needing to go through setting this up twice. So we're going to see if we've got any signals coming through. So we'll go down to the local button, and this will just display locally what is happening with the PVR device. And everything's going to plan. We have a set of color bars coming through on the video side. So if you're happy with that, just deselect the local button and hit stream, and it's come up saying MPEG-2 video, MPEG-2 sound, streaming for 3 seconds, and we're off to an IP address of 150 on the network where the QPSK modulator is sitting, running away quite happily, transmitting those color bars. So it is simple as that. So hopefully that gives you a simple rundown of how all this works. I will go into more detail on various aspects of the software